So today I thought we'd go through our stockpile of sets which we can sell on. Mark has, oh yeah, looks like that's going to be glued on. It's a just powers up set. So it has the square round power lead. It's the 2001 Fidelity, so it's the Cybernet 002F chassis. Do you know I once had a comment on either it was a 2001 or a 2000 and somebody put, oh, bleed over box. No? Isn't it funny how they produce a rubbish set like the Fidelity 1000 and so the whole brand is tarred with the same brush? Look at the Amstrad sets which use this chassis. Then you get the fake ones which use a knockoff version. And then the problem is that most of the sets in circulation are the knockoff version. Oh, they're rubbish, they are. No, they're not. Try a real one. It's like buying designer clothes, isn't it? And the knockoff ones, and so they fall apart. Well, they were rubbish, weren't they? Gucci handbags come to mind. I've never owned a handbag, but there you go. Each to their own. So, it just lights up, says Mark. So we'll put a standard replacement mic in. These are prone to being destroyed by incorrect polarity, and it destroys nearly all the ICs. It's very expensive to fix. We'll go in with the cigarette lighter lead. We won't. We don't have cigarette lighter leads. We will go in with the crocodile clips. We have new leads available, which Mr. Chippie makes with the correct mouldings, not pretend mouldings, ones imported from the United States. So, we've got it lighting up as Mark says. Let's put it on channel 20, we've got no meter lamp. Let's see if it works in PA. Testing 1 2, testing 1 2. Testing 1 2. It doesn't work in PA, so chances are the audio IC's been cooked. I bought an LA 1213 for a reverse polarited Amstrad 900, which I've not done yet, so hope we don't end up using it on that. So let's see if we can see where the protection diode is. Protection diode is there. So unless that's open circuit, we shouldn't have a problem. Right, switch the power supply off, check the diode. Well, that reads okay. Look at the printed circuit board. Can we see any shenanigans? I mean, that is such a dry joint. These sets don't suffer from dry joints, but you see where the audio IC is, it gets hot, and you've got that constant heating and cooling, and over 40 years you're going to get dry joints even on things where there aren't dry joints. So put the soldering iron on. Wouldn't it be nice if this was an easy fix? The other thing that happens is the 8 volt regulated voltage rail, if it is 8 volts, fails because the Zener diode somewhere down here goes short circuit. I think we'd have to get the circuit out too. But this doesn't look messed with. It's got the ballast resistor in place, which is also dry joint. Yeah, I can see that wiggling around. Mind you, we'll probably end up changing it because they're only 3 watt resistors and we can't expect the set to do 4 watts. So my rule of thumb is if we can get 3.6 watts or above, we let the set go, and if we can't get 3.6 watts, we change the ballast resistor for a 7 watt type. You know, I just think this has been used and used until it's failed. In fact, the meter lamp's out. So apart from where the transistors are for the output, which could also go dry joint, hence just checking, that's been soldered up. That filter's potentially dry joint. But they're the hot spots. So let's see if we can power it up again. So we're powered up, switch to PA.
1 2 testing 1 2 testing 1 2 3. Waha 1 2.
Okay, well, it's time to get a sheet of paper and we'll start writing down some parameters. There's one kicking around which I found on the floor, so we'll use that one. No idea where the clipboard is. This could be a really nice, genuine radio for somebody which hasn't been messed with. Our set, so put T21 there. We're on a road trip this afternoon. This might get published after that. I'll take the camcorder. We're going to go via Grantham when we're going to Newark. So I'm not trying to film the Grantham leg of it, but we're going to start doing some camcorder tests. But I want them in a series, like I think the first series is DVD camcorders from probably 2004. The Sony DVR DVD 91E, the 101E and the 201E are all in the same series. So I want to kind of show the three. There's our sensor differences and there's zoom differences, there's feature differences, and we're going to go past the same bit of scenery with each of the cameras. So today I'm going to take the normal camcorder out and we'll just kind of do a trailer for that. I'm waiting for batteries to come, because obviously when you buy 20, 25, 30-year-old camcorders, the batteries are always knackered. So there we go. Right, so let's go into, we've now got PA. So Dry joints, audio IC, oh, plus ballast resistor. Back in the 30s, ballast resistors were called Berettas because it looked like a priest's hat, and nowadays they're called dropper resistors, so I sometimes use old-fashioned terminology. Good. Right, we'll go into normal CB mode. Squelch down, it is down. We don't have a normal FM hiss. That can be because the squelch on these sets sometimes doesn't open if there's no signal whatsoever. Sometimes it can be adjusted, sometimes it can't. So when you get the fake version of this chassis, the squelch is what usually is the letdown. It's part of the LA1230, which is this Sanyo FM chip. It was designed for hi-fi stereo tuner amplifiers, and so when you tune between stations it mutes, so you don't get that FM hiss. So it's an internal part of the integrated circuit, and it's used as the squelch, because in two-way radio, mute is squelch. So we put in the correct frequency, 2779125, into the signal generator. I can actually hear that receiving at low strangled volume. And we can see, hopefully, the meter reacting. So we've got no received audio. I wonder if some Wally's rewired the mic. Let's go into transmit. I'll put picture in picture on. Look, we've got transmit. So, no RX audio. I'll just see, here's the biggest error in the book. I've not plugged the extension speaker in, have I? That's why we haven't got any received audio. What abject Wally? Got PA speaker in, yeah. Let's put ourselves on earth on. Okay. We don't edit out cock-ups here. Transmit. 3.4 watts on channel 20. Channel 40. 3.3 watts. We're going to get 3.5 on channel 1. We are. 3.55 actually. I'd just like it to be a little tiny bit more than that. Otherwise the ballast resistor is going to be changed. But I don't want to spend money unnecessarily. So low power is preset on these, non-adjustable in other words. And we have got 260 milliwatts. Which, considering you were allowed 400 milliwatts, was a bit overcautious. We've got 1.2 amps being drawn, 1.201 amps, which is about right for that power output on this chassis. So let's look at the deviation. Wallow. Oh, it's ridiculously high. Wallow. I'll just tell you it is 20 kilohertz. We'll put that there because I can't always trust this test set on that, not on anything else. So we're going to need to do the VCO. It's one of the things on these sets which needs checking. Without getting the service manual out, I seem to remember it's done on channel 1. So, fast, we need an earth on there. I'll borrow that earth. Far side of that capacitor. .3 volts. And on transmit. 2.28. Go to channel 40. 3.9 volts. It's spot on. If it's the transmit needed adjusting, we'd have to adjust the trimmer there, and if it's received that wanted adjusting, it's the coil there. So this one's spot on. Go back to channel 20, see if we can tune up the transmitter. So we'll have to go on the bigger scale because we're already over the 3 watts. So I want the centre of the peak, not just the peak. .8, just readjust that. Right, so it sets hot now, so it's going to do less power when it's hot than when it's cold. Chances are it'll be over 4 watts, just over, when it's cold. Channel 1. .7 watts, 3.8 watts. Channel 40, 3.7 watts. That's nice. I'll probably show you when it's cold, just for the giggles. And the low power. Remember, this is a commercial test set. It reads what's on the frequency, so if you put this on a hobby meter, it'd probably say it's doing 7 watts anyway, which it isn't. It's now doing 290 milliwatts on its low power, and its current consumption at full power is 1.335 amps. We'll come back to deviation. Let's look at frequency. Now, the test set's not been on above 20 minutes. It's supposed to be half an hour before we do anything for accuracy. You can always recheck that. Look at what camera 2 has to say. And we are on 27. Oh, I'm on channel 40. That's no good to us. 2779093. There's a bit of leeway on this. It needs to be over 100 to pass. It should be 125. There we go. It's still a bit of leeway. 2779093 to 2779125 megs. I should have done the meter before. It's full scale deflection at the moment. So we'll put FSD and we'll just twiddle that so that it reads 4 watts. Even if it isn't doing 4 watts, we always say the meter, set the meter for 4 watts. There's 4 watts. That's now correct. Meter lamp doesn't work. S meter at the moment, look at that, if you can. It's a bit generous. You know what? No, it's not. It's the opposite. Wow, I was on the wrong setting. 130 microvolts. It's about where it should be. Should be 100. Switches work. Potentiometer. Let's put that earth back on the speaker. There's nothing wrong with the potentiometers. Nothing wrong with the sockets. And the sensitivity at the moment, let's put the SINAD meter on. The sensitivity right now is very good. It's 0.25. These are capable of such good results. Oh, it's crap, it's a Fidelity. I put something really, really shocking on. I think it's good. 1.65. 0.55. Tell you what, this is one of those really good sets. Squelch. It's a full squelch. Let's put the attenuator up on the screen. If you can see it for all the junk. Full squelch. Let's see where it's supposed to be 100 microvolts. No hard and fast rule on that, but it's never opening. And threshold. 0.3. Great, well, I'll tell you what, I wish they were all like this. The only fast can be that meter. Right, let's go through. We'll start with the detector. 100 microvolts on the test set. Show you the oscilloscope. Set the detector. Miles out. That will affect the squelch. It'll also affect the sensitivity. Could make it worse. Could make it better. It's wrong. So because of that, we're going to look at the IF first. So I want on the SINAD meter about 12 dB. So go to the SINAD meter. Squelch was on. Yeah, that one was out, and then we've got the hidden one under here. Was quite a way out. Right, back to a lower sensitivity. Let's go for about 6 dB on the meter. So we're not saturating the receiver. I'll just move that to a different coil so I can get the tool in. Yeah, that was about as good as it was going to get. That was spot on. They were really good. So the detector was out, the 3IF ones were slightly out. Let's see now what result we've got for our sensitivity. I'll show you the SINAD meter instead, I think. So for 12 dB, I'm on the wrong scale. .22 microvolts. For 10 dB, it's just under 0.2, but if I change scales, it'll still say near 0.2. Just on that changeover. For 20 dB, 0.41. Wow. This'll hit a scratchy corner. Right, so let's see what we can do with the squelch. Let's go over to the SINAD. Perhaps it doesn't need adjusting. Squelch. Let's turn it to full on the radio. So I want it to open at 100 microvolts. So 3, 10, 30, 100. It isn't. So I need to adjust the preset so that it does. While I'm at it, I'm going to do the meter because that's also 100 microvolts. That's got a dirty preset. Just waggle that around. There we are, spot on the line if you can see that. Squelch to minimum, and take this signal change to standby, adjust the squelch on the radio for threshold, still 0.3 microvolts. So 0.3 microvolts, 100 microvolts, that's fixed that. S meter is now 100 microvolts. So all that remains for me to do is to do the meter lamp. That'll take as long as the rest of this set is done. Wow, that's really impressive. We're just doing the meter lamp, and it's a type which is on a little Paxilin subboard. So instead of it being the wire-ended ones we normally use, it's these, if you can actually see them in the packet. And we're using RS360 7913 when we need to solder them onto a little tag strip inside. So put those back. And the others come from Rapid Electronics. I'll just clean this front while it's off. It seems sensible. Right, let's put the front back on. Put the knobs back on. You know what, I'll probably clean these later. I'll not put them on fully, they'll be easier to take off. PA and off. RF gain. That's mic gain. RF gain. Right. So there we are with a meter lamp. That switch is dirty. Right. Let's put the lid on. See if the speaker works. Check it's still on because we set the frequency when it was, the test set was still cold. Yeah, it needs to come down. It was probably about spot on then when where it was. Leave it slightly high because they drop with age. There we, that'll do nicely. Right, unplug that, put that back on. Oh, I heard the knob for the channel display, the channel selected drop on the floor somewhere. So I'll have to recover that. That was the only thing which needed doing. Let's see if we can find something to make it even turn. They're not the normal. They're not the normal one for. And the other thing to do is just tighten up this aerial socket. And go around with the fiberglass brush. Oh, I never did the deviation, did I? No, Mr. Tango, you didn't do the deviation. It was mega high. Right. Plug into the test set. Which I haven't stupidly turned off. Something ridiculous, wasn't it? Take picture in picture after now, nothing going to show. Wow. Yeah, it's in stupid mode. Just transmitting on like 5 channels at once. Wallow, wallow, wallow. There we go. Right. It's not got any broken away lugs on this one, which is very rare these days. You know, I did that, I was looking at that Amstrad camcorder yesterday. I watched the whole 30-minute tape, and clearly the bloke was a lorry driver, and he goes to, I'm not very good at geography, but the signpost says Geneva, so many miles, and he's obviously in a foreign country. And then he starts talking to his lorry driver mate in English over the CB radio. You don't see the CB radio, but he's using a CB radio. So what's the chances of that? Buying some random camcorder off eBay, there's a tape in it, and the lorry driver's on the CB. Incredible. You couldn't make it up. So that is a really nice radio. It'd be even nicer when I find the channel knob on the floor. And put it on a proper power lead. Right, what we're going to turn this channel selector with then. The locking pliers, the locking forceps. Well, no, Roger. Oh, RF gain's right there. Roger. Right, we'll get on our road trip to Newark. That's the Fidelity CB2001 using the Cybernet 002F chassis, and that will be complete. We'll flog that as soon as I go on the floor and find that knob. Thanks for watching.